All right, so in section 2.6 of our textbook, starting in 2.5 really, the textbook really digs into equations and lots of different types of equations. So 2.5 introduces quadratic equations and a bunch of different strategies for solving them. You've studied that stuff before in your Algebra 2 class in high school, or if you took Math 250 or even 240, we do it all the way back in 240. So that'll be review. I just want to do one example of solving a quadratic equation, and then I'm going to move on and do a few other examples. I'll make a separate video for each one, but I'm going to do some other examples of things like radical equations, well, we already did a rational equation earlier, and we're going to tackle a little bit of absolute value equations actually in this example. So these examples are here to just demonstrate a bunch of strategies that you can use to solve equations. You can look at more examples in sections 2.5 and 2.6 in our textbook. So for this equation, this is set up in a particular way. This equation is set up here, y equals 2 times x minus 3 squared minus 4. This is a particular type of format for a quadratic equation. It's called, I think it's just called like the standard Vertex Form. I think I call it Vertex Form. There it is. We'll talk about that more when we get into looking at quadratics from like a function perspective. But for now, we're just going to take this equation and we're going to try to find the x-intercepts, which later we'll be referring to as the roots or zeros of a quadratic function. X-intercepts, recall, are what you get when y is 0, right? So the first thing we're going to do is replace the y over there with a 0. Now, to solve this, there's lots of different strategies. You've learned about factoring quadratics or using the quadratic formula. Both of those require that your quadratics start in the format ax squared plus bx plus c. Right, like 3 terms added together, an x squared term, an x term, and a constant term. We don't have that here. We've got the vertex form, which is different, right? So it doesn't make sense to try to expand this, like multiply out that squared there and like combine like terms. No, that's just a lot of extra work we don't want to do. Instead, let's just solve for x, right? So let's start off by just adding 4 to both sides, right? There's the additive inverse property at work right there, as well as the additive identity property, since we'd be adding 0. I'm not going to write that. All right, let's divide by 2, right? We can divide both sides by 2. Divide by 2, and here we have common factors canceling. That's the multiplicative inverse property at play, as well as the multiplicative identity property, because that would equal 1, and multiplying by 1 doesn't do anything. And then we're here. Okay, so 2 equals the quantity x minus 3 squared. Well, if we want to solve for x, we should take a square root of both sides, right? Let's do that. That's a thing you can do. If 2 numbers are equal, their square roots will also be equal. And so I can write that. And now on the left side, this is just the square root of 2. That is an irrational number. It's like 1.414 ... goes on forever, never repeats itself. It's irrational, so I'm not going to actually write it down in decimal form. We'll just represent it as the square root of 2, and when we get to the end of this process, we might end up with the square root of 2 in our answers, like writing that, literally that square root of 2 in our solution. That's fine. So we've got that on the left, and on the right, here's a bit of a weird situation. You may have learned that when you do this, you need to write plus or minus. That's one way, yeah. But I'd like to sort of remind you of something a little more fundamental than that, which is that when you square something, this x minus 3, after you squared it, you don't know whether the x minus 3 was a positive number or a negative number, because squaring something basically erases that information, right? If you square 4, you get 16. If you square negative 4, you also get 16. So you can't tell any longer whether you started with 4 or negative 4. Likewise, we can't tell whether x minus 3 was positive or negative because we've squared it. So when you take a square root of that, you're going to get a positive number. The square root of something is always a positive square root. Okay, when you write this symbol, it means we're taking the positive root. There's also the negative root, right? But this is just indicating the positive one, which means we're going to get a positive number no matter what. What is that? It's absolute value, right? We're gonna get the positive value of x minus 3, the absolute value of x minus 3, the positive version. So here, in this process, this is called the square root property, okay? And we have arrived at a absolute value equation. So how do you handle an absolute value equation? Let's rewrite it over here. I'm gonna swap the left and right sides just so that it's like this. Okay, that's a little more traditional. Okay, the way you handle an absolute value equation is you say, all right, the thing we're taking the absolute value of, this x minus 3, could either equal this value, or the opposite of this value. So we break it down into two possible cases. One is that x, that's a 2. One is that x minus 3 actually equals the square root of 2. And the other possible case is that x minus 3 actually equals the negative square root of 2, right? One of those two things must have been true in order for its absolute value to be square root of 2. So there's the two options, and then we can solve them. Let's add 3 to both sides, and let's add 3 to both sides. So in one case we get 3 plus the square root of 2, and in the other case we get x is 3 minus the square root of 2. And those are our two solutions. And those solutions are written in those are the exact solutions. They're written in exact form. Like I mentioned earlier, the answer has the square root of 2 in it. Right, and there's no way to give an exact answer without putting it in terms of the square root of 2, because of the fact that we're dealing with irrational numbers here. So if your problem ever says give me an exact answer, then you've got to type in the answer or give it to me on paper in terms of any irrational numbers that might show up in it, if there are any. Right. Otherwise, if your answer is an integer or a fraction, then fine, just give the integer or the fraction. Right. But in this case, this is the way we have to represent our exact solution. Other times, like in MyOpenMath, depending on which one you're using, which class you're in. Other times, it'll say like round your answer to 2 decimal places, in which case do that. Use a calculator, type this in and get the answer rounded to however many decimal places it requests. Okay, so make sure to always pay attention to the instructions so you know how to give your answer. That'll do it for the first example. Next one is a radical equation.